applying water quality index technique to estimate Tigris River stability for drinking in Saouira Northwest Government Iraq. Abstract. In the present study, water quality index has been used to assess suitability of surface water quality for drinking purpose in Saouira area. Surface water samples were collected in September 2015 and April 2016 from 19 samples have been modeling analysis in General Commission for Groundwater. They analyzed for their psychochemical characteristics such as pH, total dissolved soils, electrical conductivity, sodium, calcium, magnesium, potassium, bicarbonate, sulfate, chloride, total hardness, and nitrate. Each parameter was compared with its standard permissible limit as prescribed by Iraqi drinking water standards. The results showed that WQI values for the surface water of the study area ranged from 47.36 to 52.63 based on the WQI classification. Majority of the samples are falling under excellent to good water category and suitable for a drinking water purpose. Introduction. Tigris River Saouira reach in recent years exposed to industrial waste disposal, agricultural and urbanization affecting the quality of water. The increase in population and expansion of economic activities undoubtedly leads to an increasing demand of water use for various purposes. Drinking water should be aesthetically pleasant, ideally looking clear, colorless, and well aerated with no unpalatable taste and odor. However, suitability in terms of public health is determined by microbiological, physical, chemical, and radiological characteristics. Also, a number of chemical contaminants, both organic and inorganic, are found in water. These cause health problems in the long run, and therefore detailed analyses are warranted. 1. Water Quality Index WQI is an important technique for demarcating surface water quality and its suitability for a drinking purpose. It is defined as a technique of rating that provides the composite influences of individual water quality parameters on the overall quality of water for human consumption. Study area consists of recent and quaternary sediments of Pleistocene, Holocene of the Alluvium, Mesopotamia plain. 2. The area is characterized by flood plains deposits, which consist of the layers of fine sand, silt, and clay, and some gravel within deeper layers. Deeper layers. The area characterized by an arid climate of hot, dry summer. The objective of this work is determine the suitability of the Tigris River Saouira research for human consumption based on computed water quality index. The study values area is located between latitudes 38, 72, 18, 33, or 4, 45 in, and longitude 44, 21, 92, 22, sorry, 45, 17, 22 E. Materials and methods. Serve water samples were collected from 19 samples from the study area for two periods during September 2015 and April 2016. Figure 1. Each of the water samples was analyzed for 12 parameters, which are pH, total dissolved soil, TDS, electrical conductivity, EC, sodium, calcium, magnesium, potassium, bicarbonate, sulfate, chloride, total hardness, and nitrate using standard parameters of procedures recommended by APHA 1998 for the mean concentration of parameters of the two periods are shown in table 1. Water Quality Index WQI is used in this research, which is defined as the rating that reflects the composite influence of the different parameters. Water Quality Index WQI is mathematical total to integrate the complex water quality data into a numerical score that describes the overall water quality status. 5. Quality index is an important total for getting an idea about the quality of water for drinking purpose. One of the most effective ways to communicate information regarding water quality trains to policymakers and the general public or citizens in with index indices 6. The quality index does not show exact degree of pollution. Rather, it is parameters which were pH, total dissolved salts, electrical conductivity, sodium, calcium, magnesium, potassium, bicarbonate, sulfate, chloride, and nitrate were used for the calculations of WQI. To calculate the WQI, the weight has been assigned for the parameter according to the parameter's relative importance in the overall quality of water for drinking water purpose. The assigned weight ranges from 1 to 5 as shown in table 2. The maximum weight of 5 has been assigned for nitrate and TDS, for pH, EC, SO4, 3 for HCO3, Cl, 2 for Ca, Na, K, and weight 1 assigned for magnesium, 8. Thus in the figure 8L 2010. The relative weight is computed from the following equation. where was the relative weight. Wi is the weight of each parameter. N is the number of parameters. The quality rating scale for each parameter is calculated by dividing its concentration in each water sample by its respective standards as shown in table 2 and multiplied the results by 100. QI is the quality rating, CI is the concentration of each parameter in each water sample, SI is the Iraqi drinking water standard for each parameter. For computing the final stage of WQI, the SI is first determined for each parameter. The sum of SI values gives the water quality index for each samples. SLI is the sub-index of parameter. QI is the rating based on concentration of ITH parameter. N is the number of parameters on the basis of the WQI. The quality of the water is categorized into 5 stages from unfit for drinking purpose to excellent 3A table 3. Results and discussion. In order to determine the water quality index WQI, physical and chemical properties for 19 samples from the study area were analyzed for different parameters. Table 1. The statistical parameters like minimum, maximum, and mean concentration of psychochemical parameters or physical chemical and their comparison with Iraqi drinking water standards are tabulated in table 4. The pH values of the study area surface water ranged from 7.12 to 7.4 figure 2. In indicating the low alkaline nature of the surface water, the pH values are found to within the permissible limit. The TDS and EC values are ranged from 550 to 1010 mg over 1 and 842 to 1277 US centimeter respectively. Figure 3 and 4, the mean concentrate of TDS and EC exceeded the permissible limits for drinking water. Increasing in TDS and EC concentration may be attributed to the gypsum and anhydrite rocks dissolution from formation during the passage of Tigris River during the runoff from upstream to downstream. The ranges of Ca plus 2, Mg plus 2, Na plus and K plus were 37 to 113 mg over 1, 22 to 72 mg over 1, 51 to 149 and mg over 1 and 0.9 to 6 mg over 1 respectively. Figures 5, 6, 7 and 8. High concentration of calcium, magnesium and sodium ions are observed for surface water samples that that exceeded the permissible limits for drinking water, while the potassium concentration was within the permissible limits too. The range of HCO3 minus, SO4 minus 2, and Cl minus were 18 to 88 mg over 1, 114 to 430 mg over 1, and 98 to 266 mg over 1, respectively, figure 9 and to 11. HCO3, SO4, and seawater samples have concentration that exceeded the permissible limits for drinking water, the total hardness and nitrate. Values ranged from 210 to 390 mg over 1 and 0.2 to 2.1 mg over 1, respectively, figure 12-13. The total hardness exceeded the permissible limits for drinking water, while the nitrate concentration was within the permissible limits. The calculation of water quality index WQI results for individual groundwater samples shows that the QI values ranged from 37.36 to 70.12. Table 4 and Figure 14. About 52.61% of water supply can be classified as excellent water, while 47.36% of water supply are classified as good water. Conclusions. In this study, WQI has been computed to assess the suitability of surface water of 11 different parameters for drinking purposes in Saouira region. A total of 19 samples were analyzed for WQI. Among these, 52.61% of the samples showed excellent water. 47.36% of the samples fell under good water. Based on the WQI classification, majority of the samples of study area are falling under excellent to good water category and suitable for drinking water purposes.